The next presenter is Brian Curtis. He obtained a Bachelor's of Science and Master's Science degree in Civil and Environmental Engineering from the University of Connecticut from 1978 to 86. Was employed by the Water Compliance Unit of the Connecticut Department of Environmental Protection, working with on-site wastewater treatment systems, industrial wastewater treatment, and municipal facilities planning from 1986 to date. He has worked as a consultant civil and environmental engineer, and for the past 29 years has been with Nathan Jacobson and Associates in Chester, Connecticut. Currently, engineering work involves small-scale and large-scale on-site wastewater treatment and disposal systems, advanced wastewater treatment, water supply systems, and municipal engineering services. He's a registered as a professional engineer in Connecticut, New York, and Massachusetts.
Thank you. It's a pleasure to be here today to talk about a project being undertaken by the Town of Westbrook Water Pollution Control Commission. It's a passive nitrogen reduction system. It's a demonstration project. There's representatives from Westbrook are here today. Lee McNamara is chairman of the WPCC. Also, member Sid Holbrook, who's former DEP commissioner as well, and health director Sonia Marino. We've worked with them quite a bit on this project, and also with Shirley Mickens of the WPCC and John Riggio from the Public Works Department. This is it's a subsurface sewage disposal system project, but it really involves a lot of the same biological treatment principles that you are involved with municipal wastewater treatment plants. I'd like to basically give a little bit of a background for how this project originated, then talked about some of the specifics about the two designs that we're working on for the WPCC, and also to show you some results from full-scale facilities that have been installed through the Massachusetts Alternative Septic System Testing Center up in East Falmouth, Mass. The town has been, town of Westbrook's been involved with municipal facility planning, looking at wastewater disposal needs throughout the town for a long time, starting back in, I think I was still at the DEP at the time, in 1985 was the initial part of that. And then again in 1997, a second phase of facility planning was done. But basically to look at all the areas of town where there are subsurface sewage disposal systems, and look at areas that can support them, areas that have problems either due to high groundwater or poor soils, and other areas where perhaps due to high density you might have nitrogen concentrations impacting drinking water quality. So the purpose of this pilot study or demonstration project is to evaluate a newer concept for subsurface sewage disposal, these nitrogen reduction systems, to see how they might interplay with the town's facility plan that it's prepared. I should say most of these slides I've obtained from Shirley Mickens, prepared them for the WPCC, and also George Herfelder at the Massachusetts Test Center gave permission to use some of his slides. There was as part of the town's facility plan, they identified areas where some of these subsurface sewage disposal systems needed to be upgraded because of nitrogen impacts on groundwater quality. There was discussion about using alternative treatment systems, which are like mini package plants on private lots, individual lots, but that was a no-go situation in terms of DEP. I think the concern is about the homeowner's ability to operate an active treatment system. So there was a meeting held in 2017 in which representatives of the WPCC, the health department in the town, state health department, DEP officials were present, and they were discussing the concept of using a more passive type of denitrification system for addressing these higher density septic system areas. And remarkably, as a result of that, the state health department revised the health code in January of 2018 to allow this type of nitrogen reduction system under the health code as under the category of household and small commercial septic systems. The town is planning to install it on two town-owned properties, and they're assisting us with obtaining information for design of the projects. We did site testing with the assistance of the Public Works Department, and then the town assisted us with getting groundwater level measurements throughout the spring and summer, and also water use monitoring at the facility, so we can use that information for a basis of design. In addition to that, we also, in May of last year, we visited the Massachusetts Test Center with George Herfelder up there, who's done an extensive amount of research on this technology. And basically what we're talking about is a typical subsurface disposal system has a septic tank, the effluent goes into a leach field, and then it flows through unsaturated soils until the water hits the groundwater table. Very simple system, high level of treatment. However, a typical system is not effective at denitrification. It basically relies on on-site rainfall infiltration on the property to dilute the nitrogen. So when you get down to small lot sizes made a third of an acre, quarter acre, eighth of an acre, you don't have enough natural dilution to dilute the nitrogen to the below the drinking water standard of 10 milligrams per liter. Fortunately for us, a tremendous amount of research has been done with the concept of introducing another layer in the treatment process of a subsurface disposal system by using a lignocellulose compound, which is basically wood chips, wood fibers, sawdust, shavings. You mix that with the soil to provide a carbon source for denitrification. As you know from the municipal treatment plants, you have an aerobic phase where you nitrify the ammonia to create nitrites and nitrates, but then you require an anoxic phase where with the carbon source present for denitrification. So that's the concept behind this system, is that you create a layered approach where it nitrifies through an upper sand layer. Then as the wastewater travels through that, it goes into a wood chip and sand mix where it can denitrify the nitrates. There was extensive investigations done at the back to the mid-1990s up at the University of Ottawa. Robertson did research up there. Extensive research done for the state of Florida Health Department by Anderson, where they did column studies and then full-scale studies of different approaches to this. Most of the Florida studies, they would use a sand layer for nitrification, and then they would enclose the wood chip and soil mix in a liner, basically saturated to make sure it was anoxic. Then they would collect the effluent from that for disposal in a subsurface leach field area. The approach by George Herfelder in Massachusetts Test Center was different because he wanted to see if you could just have one flow-through process instead of having to collect it and build a second leach field. So his concept was to put in the leach field with the sand layer underneath it for nitrification, then a sand and wood chip layer below that without any liner, so the treated effluent would go into the groundwater without having to collect it and build a whole second leach field. So that was, he was very forthcoming on all their research information, and that's basically that's the basis for how we're designing this. The sites that the town has selected for the demonstration project, they're two municipally owned properties. The first one is right on the Long Island Sound. It's the town-owned beach, which is a tremendous resource for the town. It's a long stretch of Long Island Sound frontage on the beach, a parking lot, and there's a concession building that has a food service and also restrooms for the beachgoers. And there's an existing subsurface disposal system serving that building. Not a lot is known about what it is. They know there's a septic tank there, but it's a little sketchy as to what kind of a subsurface disposal system it has. It could be galleries or dry wells or trenches or something like that. And it's also probably a high-strength waste because of the food service and also the restrooms would have very high nitrogen because there's no dilution from shower water or laundry, things like that. They do have an outdoor shower, but that does not go into the wastewater system. Flows here are between 200 and 400 gallons a day for design flows, and it's a seasonal use. And we did soils testing there, and it's sandy soils, as you might imagine. It's right in the dunes on the beach, and the groundwater is about 7 to 9 feet below grade. This is the aerial photograph of the site, and what we're looking at is this is the beach areas here. That's the concession building. The existing system is somewhere over here. And for soils testing, we tested the area behind the building in this area. We also found out there was a endangered species that was present in the dunes over in this area. So we're trying to focus the location of the system behind the building, right to the behind the building in this area. We proceeded and did soils testing and installed groundwater monitoring wells. And then the town staff monitored those right through the spring and summer months to get a good design basis for the water table. The second building is it's the Riggio building on Boston Post Road, and it's a former town hall, but now it's used for municipal offices. And that has a small subsurface disposal system over in this area here. Consists of a septic tank and a couple of dry wells. So that's a system that we'll be replacing with another nitrogen removal system at that property. We did soils testing there. Again, the soils are very sandy, gravelly material. We did not encounter groundwater down to about a depth of 9 or 10 feet. Here's an aerial photo of it. This is the Riggio building here. Fire department's here. Route 1 is up to the top. And we'll be installing a system in this grass area adjacent to the building. And that shows some of the soils testing and the soil types that were encountered. This is just a data table showing all the groundwater monitoring and flow data that was obtained by the town. The data from the Massachusetts Test Center was will be used for design of the system. And again, this is from George Herfelder up at the Test Center in Massachusetts. But as I said before, the basic concept is you have a septic tank, then a pump chamber, so you can have a pressurized leach field system, and you have a sand layer for nitrification, and then a wood chip and sand mix for denitrification by heterotrophic facultative bacteria. This is another schematic showing the general layout of a system where you would have, you could use varying types of leaching structures, then a sand layer, then the wood chip and sand mix below that. For the project, we'll be installing what's called a pan lysimeter, and we'll install them at the base of the upper sand layer for collection of samples and testing water quality. And then another set of lysimeters at the bottom of the wood chip and sand mix to look at the differences in treatment. These are some construction photos from the test center. It's always nice to see how these things are actually built. In this case, you have the sand and wood chip mix is at the bottom. It's 18 inches thick, by the way. And the upper sand layer is on top of that, also 18 inches thick. That's adequate for full nitrification. And then the leaching structure would be put on top of that. In this case, it's a geomat being installed on top of the upper sand layer, and it's being backfilled with material, and then backfilled with topsoil and grow grass on top of it. After they did laboratory column testing and research on the effectiveness, they did 4 full-scale installations up in Massachusetts. And the flows, these facilities were about 200, 220 gallons a day. And these slides demonstrate the nitrogen removal effectiveness of just the plain sand and also of the sand and wood chip mix below that. And as you can see at this first site, they were getting The wastewater's almost 60 milligrams per liter, and they're getting you get anywhere from 20 to 50% removal of nitrogen through the upper sand layer, and in this case they got 77% overall removal through the wood chip and sand mix. So the resultant discharge was fairly low in nitrogen, 13 milligrams per liter, starting out at about 60. And this would be subject to further dilution on site by infiltrating rainfall. This was another site. They got about 67% removal versus 40 some odd percent just for the sand. So it's a significant added nitrogen removal by the wood chip and sand mix provided below the system. There's two more here. This one had a very high strength waste, which I expect we'll have with the Westbrook facilities too, because it's mostly toilet or the kitchen waste, or restaurant waste. 90 milligrams per liter, and they got down to 8 milligrams per liter average. I should point out that they found that there is as you might expect, there's a temperature effect on the efficiency of this. You really should be looking at averages, because in the winter, when the temperatures get below 10 degrees C, it impacts really more the denitrification process than the nitrification. Below 10 degrees C, they were getting increased nitrate concentrations, not as much denitrification. But in the warmer months, they're getting fairly high percent removals. And the last facility, they were getting, starting out 94 and going down to 70 or some odd, almost 80% removal down to 21. So basically, that's what's being proposed for this demonstration project. And hopefully we can come back here in a year or so and provide you with some actual data on how well the systems worked for the town of Westbrook. Thank you.